This video lesson is on interpolation and extrapolation. This graph shows how the distance traveled by a car on the highway changes over a 4-hour period. To draw the graph, we plotted the distance traveled every hour, then drew a line through the points. We can use interpolation to estimate values that lie between two data points on the graph. Estimate the distance traveled in 1.5 hours. Hours is on my x-axis, and 1.5 is between 1 and 2. So here 1.5 is on my line, which is roughly 125 kilometers on my y-axis. So y equals 125, which represents 125 kilometers. Estimate the time it takes to travel 300 kilometers. Kilometers is on my y-axis. I find 300, which is here on my line. The x value is roughly 3.75. X equals 3.75, which represents 3.75 hours. Suppose a car maintains the same average speed. We can extend the graph to predict how far the car will travel in a given time, or to predict the time it takes to travel a given distance. This is called extrapolation. When we use a graph to predict in this way, we assume that the relation is linear and will continue to be linear, and we will use a ruler to extend the graph. Estimate the time it takes to travel 450 kilometers. So we extended out the graph. 450 kilometers is on my y-axis, so I find 450. Here's that point on my line, and the x value is 5.5. X equals 5.5. So that means it takes 5.5 hours to travel 450 kilometers. How is interpolation different from extrapolation? Interpolation, think inside. Interpolation is inside your line. It's between 2 points. Extrapolation, think extra, exterior, so outside. It lies outside of my graph, and I must extend the line to estimate what the point would be. What assumption are we making when we estimate distance and time? We are assuming that the graph stays constant. Distance and time stays constant. Example, Jenna borrowed money from her parents for a school trip. She repays the loan by making regular weekly payments. The graph shows how money is repaid over time. The data are discrete because payments are made every week. This is indicated with a broken line. How much money did Jenna originally borrow? Well, when my time is 0, my money is 200. So Jenna borrowed $200. How much money does she still owe after 3 weeks? Weeks is time, which is on my x-axis. I find 3, and on my line, that is represented by 140 on my y-axis. So that is $140. How many weeks will it take Jenna to repay 1/2 of the money she borrowed? I started at $200. 1/2 of $200 is $100, which is in between 80 and 120. $100 is right here on my line, and the time it takes is 5 weeks. Could we use this graph to extrapolate? My graph ended at 10 weeks. Jenna paid off all the money at 10 weeks. We cannot extrapolate this graph because she already paid off all of the money. Maya jogs on a running track. This graph shows how far she jogs in 10 minutes. Assume Maya continues to jog at the same average speed. Use a graph. Predict how long it will take for Maya to jog 200 meters. My graph ends at 1200 meters. I can extend the line out, but there's another trick that I can use. If Maya continues to jog at the same average speed, I could solve for how many minutes it takes to jog 1000 meters and then double it. So at 1000 meters, Maya is jogging at roughly 8 minutes and 20 seconds. So if I was to double 8 minutes and 20 seconds, I get 16 minutes, 40 seconds. Predict how far Maya will jog in 14 minutes. I'm going to use that same trick. I'll find out how far she jogs in 7 minutes and then double it. So at 7 minutes, she jogs roughly 820 meters. So if I double that, I get 1,640 meters. What assumption did you make? The assumption that we made was that Maya continued to jog at the same average speed for the entirety of her run. Here is a graph of the relation y equals negative 3x plus 7. Determine the value of x when y equals 4. So I'm going to find when y equals 4 on my y-axis, and my x value is 1. X equals 1. Determine the value of y when x equals negative 1. So here's my x-axis. I find negative 1. My line is at 10 on my y-axis. So y equals 10. Verify your answers in A and B. To verify my answers, I plug in the values that I get for y and x into my original equation. So for A, instead of writing down y, I plug in 4. Right now I have negative 3 multiplying by x, but instead of putting in x, I put in 1. I'm going to solve each side of the equation separately. The left side has no math to it, it's just 4, so it stays 4. I have negative 3 times 1, which is negative 3, and I add 7. Negative 3 plus 7 is 4, so my left side equals the right side, so that's how I can verify that my math was done correctly. To verify question B, instead of y, I'll plug in 10, and instead of x, I'll put in negative 1. Negative 3 times negative 1 is a positive 3. Positive 3 plus 7 is 10. 10 equals 10. So I verify that B was done correctly. And that is it for the lesson on interpolation and extrapolation.